Okay, so here's the beginning of the your turn answer, and we had already made a bit of a motion map with the velocity vectors going downwards, and we chose to make downwards positive in this case because all the motion's downwards and it just kind of makes things a little bit easier. I wrote another motion map for acceleration where it's always downwards at 10 meters per second squared, and now does it say to draw a motion map and a VT graph? So here's the beginning of my velocity time graph. Now, to begin with, it starts off at 40, and now it increases from there. So it actually would go up from there. And there's a few things we don't know. We don't know what the time is. In fact, that's the first thing we're supposed to find out. And we also don't know what the final velocity is. So we kind of know the general shape of this. Maybe I'll make it go a little bit higher. We know the general shape of it, but there's a lot of things we don't know about this VT graph. So if first I'm going to solve it graphically for you, and then I'm going to solve it mathematically. So if I was to solve it graphically, the key for this one is, again, that the area under the graph for a VT graph is equal to displacement. So the displacement, the height of that building, is equal to 45 meters. So if I was to say, okay, this shape here, it's a funny looking shape, isn't it? It's actually called a trapezoid, if I could draw that line straight. And the easiest way to do this is to divide it into a rectangle and a triangle. So if we're starting at time equals 0, and here I'm just going to say, I don't know what the time is, right? So time equals question mark. So I'm just going to put a t here. This is time t. So what would the area of the rectangle be then? So this area of the rectangle is equal to the length times the width. The length is t, and the width is 40 meters per second. So I'm going to say it is 40t. Okay, so that's fairly straightforward. Now the area of the other part here, this area here, it's a triangle, so it's going to be equal to 1/2 times the base times the height. Now again, the base in this triangle, this side will be t, and what will the height be? Now if you remember that if the velocity is increasing by 10 meters per second for every second that goes by, if t seconds goes by, then this final velocity will be 40 plus 10 times t, because if t seconds goes by and it increases by 10 every second, and if it started at 40, then this will be 40 plus 10t. But I have to be careful. That's what this value here will be, 40 plus 10t. But this side here, how much this increased by, will be 10t. Okay, it rises 10 for every second that it runs. So from here to here will be 10t. So from here to here, this is 40. So this whole thing here is 40 plus 10t, and that's where this comes from. Okay, so if I was to figure out the triangle here, the area of the triangle is going to be equal to 1/2 multiplied by t multiplied by 10t. So the total area here is going to be 45 will be equal to the first area, this one over here, 40t, plus, if I put this together, the second area will be 1/2 times 10 times t squared. Okay, so I'm just going to leave that for a second. I'll just leave that hanging, and I'll go to my mathematical area. So my math, I'm going to say, well, my initial velocity, and again, it might look better to look at my diagram. My initial velocity was 40 in the positive direction. My final velocity, I don't know. My acceleration is 10 in the positive direction. The time is what I want to find out. And my delta y was equal to 45. So again, I'm going to use equation number 1. I'm going to say delta y is equal to v1 or VI. I switch between V1 and V2 and VI and VF. How's that? VI delta t plus 1/2 a delta t squared. So in other words, 45 is equal to 40 times delta t plus 1/2 times 10 times delta t squared. So you see that this is actually the exact same math. So, and now I just need to finish this off. And I think I'll do the same thing here. Once I clean this up a bit, I'm going to do the same thing I did before, and I'm going to substitute an x for delta t. And then I'll solve it. Okay, so when I solve it, it looks pretty well like the same quadratic equation that we did before, and we end up getting either 1 second or -9 seconds, so I chose the 1 second. And I think the last question we had to solve was how fast is it moving when it hits the ground? And we could get one of the equations out, V2 is equal to V1 plus a delta t, but really when you're thinking about it, if it was going down over here, if you look at our velocity time graph, if it was going 40 meters per second and it actually hits the ground 1 second later, so it'll be if I did a dot every second, oops, oh, how did we lose that? Here, if it hits the ground 1 second later, here's will be going 50 meters per second. So if it was going 40 meters per second downwards, 1 second later it'll be going 50 meters per second down. Alright, so hopefully that was helpful for you, and I'll see you in class.